Have you ever wondered if two things are really connected or if it's just coincidence? For example, does studying really affect whether a student passes an exam? In mathematics in the modern world, we don't rely on guesses. We measure relationships. One way to do that is through phi correlation. But what is phi correlation? According to Akoglu 2018, phi correlation, also called the phi coefficient, is used to measure the relationship between two binary variables or variables with two only possible outcomes. These values are usually organized in a 2x2 contingency table. A 2x2 contingency table is used to organize data from two categorical variables. It is called 2x2 because it has two rows and two columns forming four boxes. These four boxes are labeled as A, B, C, and D. A is the count where both variables are present. B is where the first variable is present and the second is absent. C is where the first variable is absent and the second is present. And D is where both variables are absent. Once the data is placed correctly into the A, B, C, and D, the table can be used to compute the phi correlation. The formula for phi correlation, as explained by Bobbitt in statology, is phi equals AD minus BC over the square root of open parenthesis A plus B times C plus D times A plus C times B plus D close parenthesis. Now let's try an example. For this example, we will use hypothetical data created only for demonstration purposes. Let's say we are checking the relationship between studying and passing an exam. A represents the number of students who studied and passed, which is 18. B represents students who studied but did not pass, which is 6. C represents students who did not study but passed, which is 4. And D represents students who did not study and did not pass, which is 12. Now that we have identified the values of A, B, C, and D, we can now substitute them into the phi correlation formula. After substituting the values into their corresponding variables, let's proceed to solving the equation. 18 multiplied by 12 is 216, and 6 multiplied by 4 is 24. 18 plus 6 is 24, 4 plus 12 is 16, 18 plus 4 is 22, and 6 plus 12 is 18. Next is 216 minus 24, which will be equals to 192. For the denominator, we will multiply 24, 16, 22, and 18 to get 152,064. Then take the square root, which is about 389.95. So, the phi correlation value is 0.49. But this isn't our final answer yet because we still need to interpret what it means. According to the common phi correlation scale, values range from -1 to +1. Our result of 0.49 indicates a moderate positive correlation. Thus, the relationship between studying and passing an exam has a moderate correlation. In summary, phi correlation helps us measure the strength and direction of the relationship between two binary variables using a 2x2 table and a simple formula. That's it, everyone. I hope you learned something from this video. Thank you for watching.